eccentric load will now be transferred to the center of gravity. It will now compose of a torque or a moment and a direct load. So after that, we have to compute the stresses due to these two loads. Na kay twisting or moment load, and then yun na po kay direct load. So TR over J ratong twisting, niya ang direct is of course K over A. So after that, once you have computed that, then we are now going to locate at what portion of the welded group of welds is the highest stress. Because usually in design, we look at the weakest point. So meaning the point where there is the highest stress is the weakest point. And our guide for that is that it is the farthest from the center of gravity. So once you locate that, then we are going to examine now the effects of the two stresses on that point. If we have already determined the point where there is a greatest stress. Okay. So let's, and of course, finally, we have to determine the resultant because there are two stresses acting on that point. The resultant stress, which is which we have to review our addition of vectors. The resultant is the sum of the vectors. The vectors due to the direct stress and the vector due to the twisting. Okay. So what we have here, if you will notice, okay, forget first about what is inside. No? What we have is a bracket. Okay, as I have mentioned to you last time. It looks something like this. So you have a bracket here. No? And then your welded portion is this one is here. This one is here. Okay. This portion here is in the front. And dark one. And this is also, this portion is also here. And this portion is at the back. At the back. Do you get the picture of the drawing, representation of the drawing? Class?
Yes,
Class,
sir.
do you get the picture? Okay. So this is the bracket. Sorry, this one is the bracket, and behind it is another metal where the bracket is welded. So kini is another metal behind this bracket. And then our eccentric load is 7,500 pounds, which is 6 inches from the edge. And then the length of this welded portion is 6, and the length of this is 8. Okay, so again, we have first, as I have mentioned, we have first to determine the center of gravity. So meaning we have 3 group of straight welds, rectangular ni atong area ani is a rectangular, no? That is the length. The width is the throat area. For a fillet weld, pila man ang width sa fillet weld? This is a fillet weld. Pila? If it is a butt weld, pila ang atong kuan? Throat area. What is the throat area for a butt weld? Okay, for a butt weld, the throat area is the H times the length. How about if it is a fillet weld? 0.707 times the length. Okay. So since these are fillet welds, as I have mentioned, so it should be fillet dire og dire sloyo. Okay. So we have first to determine the center of gravity. As you can see, it is symmetrical if you look at the horizontal, no? Horizontal axis. It is symmetrical. So this side and that side, since all of these are, what is the size of this weld? 1 inch? Ay, nara. Sorry. It is a 1/4 inch fillet weld. Okay. So all of these are 1/4 inch fillet weld. If you look at the horizontal, it is symmetrical, no? So asa man ang center of gravity? Where do we expect the center of gravity if you look at it on the horizontal direction? It should be in the middle of, because you have a group of welds here and a group of welds here, which are mirror. Okay, so we expect it to be on the middle. However, on the vertical, this is not symmetrical anymore because this one is symmetrical on the vertical, but there's one here and there is none here. So we should expect the center of gravity to be closer to where the other weld is. Okay, wala man ni siya, blanco man ni dire. There is no weld here. Now, how do we determine this? Okay, if you will recall, sa center of gravity gani? Huh? Barred Y total area is equals to barred Y1, area 1, plus barred Y2, area 2, and so on. Can you remember this? Okay.
Yes, sir.
So, if you have remembered, if you did not get this in the first exam, make sure you do not, you already know this, no? Because this is always coming back, no? It's always coming back. Okay. So let's try to look at how do we locate this. So we say total area is this one, that one, and this total area, no? Barred Y total area is equals to 1, area 1 plus area 2, and so on. Now there are three. So the total area is, of course, this one plus this one plus this one, which is 1/4. Saman. Times total area of all the welds. We want this. Asik kini. Saman. All of these are 1/4 inch fillet welds. Throat area. I'm talking of throat area, huh? We are not talking of throat area. Any idea for those who are connected online? Okay, what is the throat area of this one? This weld? 8
8 times 6, sir.
times
6, sir.
8 times 6 for this weld.
Ay, 8 to 1/4, sir.
8 times 1/4
Times
of cosine of
0.7.
0.707. That is only for this one. So for the other one,
0.
6 times 1/4 times 0.707, and this is also 8 times. Okay, so you have actually, now you will notice that all of these A's, kaning tanang A, have 1/4 times 0.707. So actually, since all the welds are 1/4 times 0.707, you can actually cancel all of them. So you will only deal with the length. Be careful, because if one of the welds is not 1/4, then you have to include all of those. Di mo na makancel, you can cancel it. Do you get me? Do you get me, class?
Yes, sir.
Yes, sir.
So the throat area for all of this is already cancelled. Oh, no. The throat length ra siya, kanang width ra ba? Throat sa width is being cancelled. Ang length ra mo ay dili ma-cancel. Okay. So that is why in determining for the center of gravity, our basis is on the top well. Dire. No, reference na to is on the top well. So we say this is actually the total area. 8 plus 6 plus 8, that's the total area. But you have cancelled already the square 1.707 times 1/4. So length ra atong kuan is equal to this one. What is its distance? It is 4 moment arm. Yang length is, and for the other one, for this one, 0 because it is on the reference. So that is why our center of gravity from the top weld only involves 2. Kay kining third is 0 ang iyang moment arm. So we will get this. So we have this one, no? That is 2.909091 from the top weld, but it is located midway between the 8 and the 2/8 vertical welds. Now, for the total area, because we need this total area for the direct shear. So the total area is, we have to include 1/4 0.707 times all the welds, which is 8 plus 6 plus 8. And this is our total throat area. So, total throat area ni, no? Any questions so far? After that, we are going now to transfer this one here. It will now be ana siya o ana. No? This is the 7,500 and this is the twisting. No, if you recall, can you recall that if you have a certain, and then you want to transfer this about this center of gravity, you say it is that one and this one, diba? This will cancel. So, mura gyapon na sa original. But this one is now a moment. Wala na. So now, there are two now. We have a twisting and we have a direct stress. Lisod man pag-drawing diha kay kuan man, no? But this one is supposed to be here. Huh? We have a direct and a kung nila i-drawing. Direct and a twisting. Acting on the center of gravity. So, the direct stress is, of course, how much is this? It's just been transferred. So, 7,500 divided by stress throat area, which is this one. So, our direct stress, shearing stress is 1,928.764 psi. Okay. Now, let's go to the twisting. Okay na ni siya. Twisting upon. PR over J. We'll start first with the T, the torque or the moment. It is, of course, the 7,500 times the distance. And the distance is this one plus. So it is 9. So our moment or our torque is this one. Okay. Next is the polar moment of inertia. Polar moment of inertia. Sa ganito? Oh. It is area length squared over 12 plus the distance between the centroid of the 12 to the centroid of the group. For the top 12, what is R? What is R? This one. What is this one? If you look at this. The distance between the centroid of this 12 to the centroid of the group, which is okay. So area is 6,707 times 1/4. This is the length. That is the throat, no? And then times length over 12 times this one. So that is now, we have transferred now the moment of inertia of the top 12 to the about. The reference is now about the center of gravity of the group of wells. We have to also do that to the others to complete. Now we can add them algebraically once they have the reference is the same. So we have again to determine the reference of this one. From here, kaning AL squared over 12 is from about here, but if you want to transfer it here, you need the R1 squared. Okay. Now, for the vertical welds, we have to determine the distance between the, okay, we need the R1 squared. So we need the distance, just like here, we need the distance from here to here. So we need the distance from here to here, because this is the centroid of the 12, and this is the centroid of the group. And how do we do it? Okay, we know this is 3, and this is 4 minus this one. Okay, so 3 squared, 4 minus. And so our R1 for the vertical we're talking of the left side. But anyway, on the right side, it will still be the same. Okay? So for the vertical weld, it is length 0.70714, length squared over 12 times the distance R1. And so the total, we have now determined the polar moment of inertia of all the different welds about the center of gravity. So we can add them all now directly because the reference is the same. By the way, for this weld, it is the same as the other one because our R will still be the same. Length, everything is a mirror. So our total polar moment of inertia is the top weld plus the vertical weld, but there are two. Okay, so if we add this plus double this one, we will get this. Okay, so far okay na ta ana? Do you follow? Any question? Class, any question? Wala ra? Okay, so if I hear silence means okay ang tanan, everything is okay. So the next part here is to determine the maximum because we now have J and our twisting here is TR over J. We already have T. We already have J. However, what is the R? And what is the criteria to determine R? It should be the farthest kay TR over J. So ang kinadakan nga R mo, gunay mo hatag og dako nga TR over J. So where is the farthest from the center of gravity? It is either here or here. Okay. Now, if we draw the stress figures or stress vectors, the direct stress is downward. So for here, downward po siya. But for the twisting, it is perpendicular to the radius from the center of gravity to where it is located, perpendicular. So probably that is my best approximate to the perpendicular. For this one, by the way, look at the direction, ha? Parang dito. Look at this. So that is my best approximation of a perpendicular. If you look at the resultant of all of this, you will find out that the resultant of this one is here, and the resultant of this one is here. So where do you think is the biggest? This one is the resultant, while the other one is here. So it should be where? At A. So we are now going to concentrate on our analysis on the A, where the resultant stress, which composes of the direct and the twisting shear, will be greatest at A. Okay, so far. Any question? Okay. Question? Are there any question?
None, sir.
None. Okay, sige. So, Again, the maximum stress will now occur at A because it is farthest from the center of gravity and it will give us the bigger resultant. So, what is our radius? Because T R over G man eh. Okay, so our radius is again, how much is this? So 8 minus this one is this one. And 3. No, to get the radius. It is the square root of 3 squared plus the square of 8 minus 2.909. Okay? So that is how we got this. Ay. Sorry. Sorry. 8. Sayop na siya. 5. I correct. This one. Ah, that's correct. Naman rin. That's correct, no? Because akong 8 minus 3 is this one. It is here. Class, it is here, no? 8 minus this one. That is this. Squared plus this one. 3 squared. Okay, class? So that is the radius. Or that is the radius of the TR over J. Katong TR over J. This one. So we now have R at A. So our torsional stress is TR over J. Of course, everything is already given or computed. Torque is, we have already computed it at 67,500. Our R at A is this one. And then our J, we have already computed it. And our reference is now the center of gravity of the group of welds, which is 56.56, So, our twisting shear is 7,115.382 only here. Dirira. Huh? Because if you transfer to the other points, line man silag R. It is TR over J. So, it is also the same here. Because it has the same T, the same R, and the same J. However, we again concentrate our analysis here because it will yield the greatest resultant. Okay. So, the next question here is actually to determine the resultant. Determine the resultant. So, we have here the TR over J. Kine is our twisting. Kine is our direct. And this is our resultant T. Okay? So, to simplify it, I have drawn this, no? Kine o kine. I have drawn this separately so that we can analyze it. So, if you will notice, this is our twisting perpendicular to the 5.90909. And then this is our direct going downward. And this is 5.09, no? Narao. All of these three, kini sila nga mga kuan, are these triangles. Are these triangles, no? And then next is, how do we determine the resultant? So this is the twisting shear. We divide it into components. No? So the vertical component of the twisting shear is T sub TV, and the horizontal component of the twisting shear is T sub TH. And then you add these two. You add these two to get then extract the square root. Okay? So the vertical component of the twisting shear is sine, this is theta. This is also theta. You can get the value of theta, but since I already know this one, kininulay akong gikuan. Gamit. Because like here, this vertical component. So this component is sine theta. Sine, it's opposite to the angle. So sine here is actually 3 over the hypotenuse. If you want, you use your calculator, you find the angle. And then store the angle in the memory. And then try to multiply it here. 7,115.382 times sine of that angle, sorry. What about to verify? Find this angle. How do you find this angle? You can say arc tangent of this one over this one, or arc sine of this one over this one, you know. Depende. How do you find this angle? Arc tangent of this one over this one. Arc sine of this over that. Or arc cosine of this over that. Parehas na sila tanan. It will give you the same angle. Insakto? Your angle is how much? How much? 30. Theta here will be equal to 30. Zero to 3. Anara? Okay. If you want the angle. But in my case, I just use the sides. Because sine is this one over that one. Cosine, that one, the opposite over the hypotenuse, while cosine is the adjacent over the hypotenuse. So for the horizontal component of the twisting shear, it is this one. Is cosine, huh? Twisting shear cosine of the angle, which is again cosine is this one 5.09091 over 5.909090. Or again, you use this if you want. You can use that and extract the cosine of that. It will give you this one. So to find the resultant, this is by components. You add all the verticals squared plus the sum of the horizontal squared. So for the horizontal, there is only one. But for the vertical, there are two. Okay, so this is for the horizontal, which is this one. Vertical is the direct and the component in the vertical direction of the twisting. Okay, no? 3 point na. And the direct is this one. Natong direct dito, no? On the other side. This is our direct. We have already computed it earlier. So this is our direct. And then this is the component in the vertical direction of the twisting shear. So now, our resultant is actually something like this. Hindi maigo. But probably somewhere like here, no? Adere ang atong resultant. Siguro. Siguro dahil. So it is this one plus that one. This is by parallelogram method. This is our resultant. This is our resultant. Huh? Okay, after we have determined the resultant, of course, the factor of safety is the yield point in shear over the actual stress in shear. Okay, so 0.5 yield point in tension man siya over the actual, so it is 3.02. Is shear mode in degrees? Okay, usahay ka ng mode. Mabalhin mo to radians or to kining isa ng isa. Okay, so far, any questions? So that is the whole procedure I have outlined last time, no? So make sure you will notice that all your knowledge or lessons, be careful with this one, ha? Kay basig. The center of gravity. It was simplified because all their fillet sizes are the same and all their kanang nice square 0.707. 0.707 times 1/4 has been cancelled. Okay, class. So again, be careful with this. Kaya basig, pasagad ra mo ko niya. Dili di ay puros 1/4.
Ako question na, sir.
Yes, go ahead.
Isa ka lang 4, sir.
Ha? Asa man na
Ay.
4?
Kay nas numerator, sir.
Asa ane? Kini?
Oo lang. Oh,
Okay. If we look back to this formula, what is 8?
length.
Oh. So that is the length. Actually, it is for the area. Kay gi-cancel man nato ang 0.707 times 1/4. So, unsa may tapad niya ana? Unsay pares niya? Unsa man?
Area, sir.
Dili. 8 and 4, 8 and 4. Kini is the total length. Do you get me? Hello?
Yes, sir.
These are the total length of the welds because this is supposed to be areas. But since each of these will contain 0.707 times 1/4, 0.707 times 1/4, and also on top, then we cancel the 0.707 so that it will be simpler. Rather than you are going to compute all the 0.707 and the 1/4. Okay? So, the 8 here, the 6 and the 8 are already the length, but they represent the areas because we have cancelled the 0.707 times 4. The 8 here and the 8 here are also the lengths, but they represent the areas. Okay, gi-cancel naman nato itong 0.707 times 4. What is 4? According to the formula, unsa man na siya? We have
Y bar.
already the area. Oh, what is Y1?
Centroid to reference.
Oh, centroid of the 8 to the reference. Our reference is where?
On the top,
Top
sir.
12. Oh, sige. Do you follow?
Oh, okay na, sir. Okay na, sir.
Okay na. So, if you can remember the principle, you just write everything. 1/4 times 0.707 times 8 plus another 1/4 times 707 times 6 plus another 1/4 times 707 times 8. Then on top, more gihapon, butang gihapon. And then you will notice you can cancel the 1/4 times 0.707. Do you understand?
Yes, sir.
Huh? At least this one, we have already canceled it so that it will minimize errors in your calculators. Again, warning, if not all of these are 1/4, if one of these is not 1/4, you cannot cancel the 1/4 in all of this. You have to include, huh? I-appeal yun mo to 1/4 and 707. Yeah. Probably this is 1/2. Oh, so kini will now be 1/2. 1/2 times. Kini will be 1/4. Kini will be 1/4. Kini will be 1/4. Kini will be 1/2. Kana will be 1/2. Nap, ang 0.707 makancel to tanan. Do you understand, class? Huh? Wala na question?
Yes, sir.
Oh, yes. Go ahead.
Kana galing sa ako, sir. Kaning sa parallelogram. Na chance
Oh.
nga kanang sa pika, sir, mas dako kaysa sa 8.
You will notice automatically nga kini siya dako gunis gamay gunis siya ani. If that is the condition, wala, yun na gunis siya. So probably if we try to reverse it, probably it will be in that direction na. Kini will now be in that direction. Nya kini will now be in that direction. So what will happen if we reverse?
Po ang pikas.
No. Mo ba? Are you the one that's asking the question?
Yes, sir.
Okay, sige, sige. Let's illustrate. Na-adder itong isa, ang kanarong kuha nato is ana o ana. Di ba? Nya kini siya will be ana o ana. Di ba? Do you follow?
Yes,
Do you
sir.
follow? Oh. If we try to reverse it, let us see what will happen. So this one, meaning it is not anymore this way, but that way. So what will happen? Kini will be that way, kana direct na to. Kini will be this way, kana ba direct na to. Kung sa may nahitabo. Ano sa nahitabo?
Gamay
This
ng
is your
pikas.
Ha?
Gamay ng pikas, sir.
Oh, may gamay. Sa naman to kini. Did I answer your question?
Yes, sir.
Oh, sige. Ako ra na ibutang diha. Any other questions?
Sir.
Oh, yes, go ahead.
So, kana nga pag-determine kung asa ang longer or ang shorter, sir, kay visual or dyan sa mo i-determine, sir?
You can determine it by computation. And it will find out that because this is by parallelogram method.
Sige,
This
sir.
is by parallelogram method. So, of course, you will know that this is visually obvious nga kini shorter. Kay kini siya, actually these two are similar, but if it is from here to here, mo punta na siya. Do you follow?
Yes, sir.
Similar ni sila, oh. Kani nga mga kuan. But it is from here to here, that is also from here to here, but it is this one. So, klaro kaayo nga, mas mubo ni siya kaysa kana. If you will notice, this side corresponds to this one, and this side corresponds to that, and this side corresponds to this one and this one, no? So parehas sila lang nga parallelogram. Pero it's obvious nga as a kuan. Any other questions? Wala na? Any other questions? So, you take your screenshot, no? You take your screenshot. Ako lang na i-resolve kay kana kinisya na naman na dito. Are you done with the first board? Are you done?
Yes, sir. Yes, sir.
Unsa to?
Yes, sir. Darami, sir.
Okay, so let's look at the other board. Are you done? Are you done?
Yes, sir.
Okay, so I'm going to ask you to turn on your cameras. Mga mangkuha na po kog volunteer nga ma-raise ha. Nya na. Ako sa ikuan. Turn on your cameras, please. Turn on your cameras. Okay na ta? Okay, class? Are we done? Okay, so thank you for this afternoon's class, for joining and
Thank you,
successful.
sir.
Reminder for our exam, ha?
Yes, sir.
Wala na tay kuan. O kung sa atong schedule final na to. Dili pa last time nga nay.
Ay, sir, excuse me, sir. Sa next week, sir, mag-klase pa ka, sir?
Yes. Napay atong kanon. Napay wala na to ma-cover.
Yes, sir.
Okay? Any more question?
No, sir. None, sir.
Okay, sige. Bye.
Thank you, sir.
Yes, sir.
Thank you.
Thank you, sir.
Thank you.